Good morning, everyone, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. This session will run over the next 60 minutes, including Q&A. But before we begin today's session, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. So please feel free to drop all your questions in the chat section. Let me bring in Bhushan, our speaker for today's session. There you go.
Thank
Over
you,
to you.
Rashmita. Thank you, Rashmita, once again. And hello, good morning, everyone. Um, Thanks for joining in. I am Bhushan Gavle. I work as an Azure architect and solution specialist at Rapid Circle India. And I'm really excited to talk to you about how AI, together with something called as Model Context Protocol, is changing the way we do QA automation for different applications, including the web apps. Now, just a quick bit about me. I work with a lot of data, AI, and automation, and I have seen firsthand how these technologies are evolving. So, join in as we go through the session of AI powered QA automation. For the sake of bandwidth and keep the content focused, I'll be turning off my video feed, but I'm here. Feel free, as Rashmita mentioned, to drop your questions, comments, notes, and time to time, I think I'll also open the forum for any questions or any discussions that you may want to have. All right. Okay. So, with that, let me bring you the agenda of today's session. So here is the thing that we are hoping to cover. So I'll talk about how AI has traditionally interacted with different tools. So how we have reached to a stage wherein we needed something like MCP. So whenever I say MCP, it's Model Context Protocol from now on. What exactly is this thing? Why we need that MCP for QA automation? How it could help us. Then I'll introduce the actual implementation, which is the conceptual implementation that I have done for a sample web application. We'll also go through the benefits for QA engineers, and with the shift in the dimensions now, what are the essential skills, AI skills in particular, that new age QA should be aware of. We'll quickly cover that part as well. And then we can also talk about the possibilities of extending this concept that I am about to present. And towards the end, we'll conclude and also again open the forum for any questions and answers. All right. So moving on with the traditional AI tool calling. So as we are all aware, right? So the large language models, these are consider that as a service that helps you to generate content. Yeah. But LLM in itself is not that useful in terms of when you really want to generate some meaningful results for your business scenarios, for your business use cases, because it is not aware of that. So that becomes a challenge for these AI models to be useful. They need to access things like, it could be your own API, your own service, your own real world applications. And there is something called as tools that we all have seen in past 6 to 8 months, that how people created the concepts like RAG, retrieval augmentation generation, wherein we ended up calling different tools. Now these tools, when I say tools, are nothing but functions that you can code. These functions can access your line of business data, external services, and etc., and then give that response back to large language models so that it now knows your question plus that retrieved data. Yeah, so that then it becomes a little more useful to you. Uh, as you can see in this diagram as well, this is what the typical tool calling flows looks like. So wherein at the top you see the user who is asking the question to your AI application. Now, AI application is responsible for talking to large language models on the extreme left that you can see there. And now with the tool calling, what LLM does is when you talk to LLM as an AI application, when you talk to the LLM, you say that, hey, help me answer this question. And here is the tools or list of tools that are available for you. What LLM does in that case is it says, okay, fine, I understood your question. I see that you also have given me list of tools. Let me decide which tool I would want to be using. And it gives me the response back saying that, okay, here is the way I could help you. I want to use this tool, call this function. Here are your inputs for that function. Now, because the response is back on the AI, you are responsible as an AI application developer to ensure that you're calling that tool, which then invokes your code, gives the response back to the LLM again. Okay, so it's a multi-turn conversation thing that is going between your application and LLM. Now, LLM is of course aware of that question, and now you have response from your function output as well. And then LLM again takes control. It says that fine. So here is the formulated structured response for your application. And then as a user, final user gets to see the answer. And then user thinks that, oh, okay, these large language models are really smart because now they have helped me to give answer to my very specific question that the primary training data set of LLM was not even aware of. But then this is that layer of abstraction that you are adding as an AI application developer. Okay. Now, as we saw, right, it's just a function call. Consider a tool as a function call. Now that function, because you control that, you can call anything, external service, your applications. But then you can probably already imagine the amount of complexity involved here. Because and this example currently is only showing one depiction of one tool calling. But imagine that I wanted to write an AI application that could also help me do several tool calls. So it could be, hey, find me top rated restaurants near me. Yeah. So then, as you can imagine, it needs to call the location service first. It needs to call some restaurant service providers. It needs to call some rating service, order that by ratings, and then give me the responses back. So as you start to integrate a lot many tools, it starts to become a bit complex because each call is independent and it becomes hard for even you and large language models to maintain that context across multiple interactions. And the overall application lifecycle management becomes messier and complex. Okay, so this was tool calling traditionally. Now, what we have seen is now shift from doing this tool calling to model context protocol, which is the next slide. So this is still a tool calling. One can say that under the hood, this is still different tool calls that you end up making, but then it brings a standardization for these tool calls. The way AI models interact with different providers. So when I say providers, so these are different function wrappers that are written on top of the core functionality. So say, for example, I have been running the API, which used to cater to my customers with the weather data, right? But then in previous example, as we saw, some AI application developer wanted to interact with my API. So he had to write that code on its own and then make that call. Now, with this MCP concept, what I can do is I can just build up an MCP server and I let any AI application or any developer to come in and then leverage my services. What I mean by that is, as you can see on the right, so on the extreme bottom, you see the MCP architecture. It consists of the MCP server, which is where that abstraction, the wrapper of services that I talked about that exists. You have the MCP client who is responsible for interacting to that MCP server. Okay. Now MCP server, because it's an abstraction layer, it ends up calling the underlying business logic and services. So the weather API, say for example, in the concept that I talked earlier. So that ends up calling the actual resource and gets the response. Server then forwards that to client. Now client then gets back with the response to the LLM, and then my application is aware that, okay, this was the MCP server I integrated. This was the list of tools that I had available, and this was the executed function calls response. And that's how I get the answer back to the user. So the core concept remains same, but as you can imagine, now because there is some standard way to connect to these different services, so all I need to be aware of is just ensure that I'm connecting to that MCP server that exposes list of tools and resources to me, and I am done. So imagine that as with an analogy, as in you are just bringing in the USB, right? Because everyone uses these laptops. We have been using those. So doesn't matter, right? So we just every machine has a USB port. So it doesn't matter that to which USB port, which is the manufacturer of the USB device that we are connecting to. We just get that USB device, plug that in. So consider laptop as your application or LLM facing application, and then you're just getting that USB stick to connect and then access that data. Yeah. So that's basically MCP in general, and the benefits, as you can already imagine, because you are adding that layer of abstraction. So you don't own, or you as a developer doesn't have that onus of maintaining the layer to establish those connections, get the list of tools, and then have those functions executed. There is some standardization that is going in that space. That's what the second point says. Like models can perform standardized operations on these resources, like because MCP server, it's if it is exposing read, write, list, navigate, click functionality, for example. And we'll talk more about this. We'll also see this in action as well when we dive into the demo. And because it's stateful, so it becomes easy for large language models to ensure that the operations that it is requesting from the MCP server to get executed are called in a certain fashion or in a certain sequence that helps to generate the final set of results and responses. All right, with that, I'll take a pause here, and because now we are shifting gears and then diving into the area of how we can leverage these MCPs for QAs and then how they can achieve that automation using those. But before we go in there, Rashmita, if there are any questions that you see in the chat, let me know. Otherwise, we can move on.
Pushan, we are good. We can move on.
Thank you, Rashmita. All right, then why basically we have these MCP for QA automation? Now, if you are a QA, you might be easily able to relate to this. The way we have done the automation testing using some scripts, frameworks like Selenium. So it works, but then it becomes really, really tricky and painful in the long run, because if you are writing your scripts parallel to development cycle, then the moment developer changes some HTML elements or UI elements, then it essentially impacts the scripts that you may have written. There is a bit of an automation that you can still achieve to deal with these scenarios, but then overall, it is very prone to errors. Now, with MCP, what we can do here is, as you can already imagine. So the AI could interact with your browser resources, um, and ensure that it is simply focusing on the required operations. You can just give instructions in natural language like, hey, open this URL, click on this button, ensure that you're adding this value in the text box, press the enter. That way, you can do all these validations without even writing a very specific scripts that we have always written. You know, um, what MCP does in this case is it just simply translate those and then ensure that it is instructing the LLM to perform certain operations using the required or the provided inputs. Okay. Now, how is this helping basically? Yeah, because the very first factor I could think of is the adaptability, because you are not responsible for coding anything specific, like the CSS selectors or XPath selectors that you used to write in those frameworks like Selenium. It is steering away from that. Okay. So any UI layer changes, it kind of becomes immune because your instructions are driven by natural language. You can easily handle a different complex workflows. I'll also demonstrate that to you, how you can do that. So it could be multi-step scenarios using MCP, like the way I explained. Open this browser, launch this URL, go to a particular section on that web page, click buttons, observe the behavior, take a screenshot even if required for any error scenarios or any success scenarios, save those results somewhere on the file system. So these sort of complex workflows that you can still achieve, still using natural language uh, instructions. Then the resource integrations part, uh, as we saw earlier, right? So there are different MCP servers that your AI application could need to be aware of to perform a very specific set of operations. In this case, for this example, what we have done is we have integrated two MCP servers. One that gives my application or LLM capabilities to launch the browser and perform certain operations. It's MCP server called as Playwright. And second is because we also want to ensure that we are offloading all the work of test plan generation, uh, test plan execution, result capture, screenshot capture, etc., to LLM again. So of course you will need to save those results somewhere on the file system. And that's where we have incorporated the file system MCP server as well. So that equips my LLM to save those results back to the file system of the server where this code is executing. For now, for this demo, because the code is executing on my server, so of course my MCP servers are hosted locally on my server and they are able to access my local file system, also launch the Chrome isolated browser instance that is installed on my system, but nothing stopping you from running this on a different machine and also let it interact with a remotely hosted MCP server. There is some concept called as the way you want to connect to these MCP servers, because not every time, every MCP server you might want to host locally and interact with it. There are some MCP server providers that expose their MCP servers. They are hosted somewhere, maybe on some other cloud, and your AI or LLM's job is just to ensure that it is able to reach to these MCP servers and talk to them. So there is something called as the transport mechanism, but we'll not dive into the details of that because that will derail us from the focus of the current demo and the scope. But yeah, feel free to explore these concepts as well in detail, like STD, IO. I'll talk about that while we go through the code as well, and the SSE based connections too. But yeah, this is why it becomes very helpful if we bring in the MCP for any efforts of doing the QA automation. With that, I'll move on to the next topic, which is now more focused about the implementation that I have done, which you would of course find in one of the open source repository that I have created. And all of this code that I'm going to walk you through the demonstration, you can find it all there. I have also included the link towards the end of the session on the last few slides, I think, on this tech. Okay. Um, so yeah, this is that implementation overview. So what we have done is we have tried to build autonomous QA system for web applications particularly. And as I was saying about two MCP servers integration, one is your Playwright that equips LLM to launch or do browser operations, and second is the file system. The core idea is again is to understand the web application, offload the work of letting LLM analyze the web application, create a test plan for you, also execute that test plan by launching browsers, perform operations on the browser, and capture those reports or results of those executions and save those on the file system. So the key technologies I have used here is OpenAI Agents SDK, which is an multi-agent framework SDK that is available for you from OpenAI. For large language models, I have used one of my Azure subscription to host the large language model. That's GPT 4.1 or 4.0 that I have used here. That is my LLM facing side. The Playwright and FSMCP we talked about. And last is all of the code that you will find this reference repository created. It's a public repository, so feel free to download and take a look. So all of the code you will find in Python. Okay, but yeah, there are other languages as well. It's not restricted to Python. You can choose any framework, any agent framework of your choice. There are others as well. AutoGen from Microsoft, LangGraph, which is also out there. You get different language SDKs as well to interact with these frameworks like .NET. If you are a .NET developer, you can choose C#. But Python, I personally feel that sometimes it becomes easy with Python. All right, so that's our implementation overview. And with that, I also would want to walk you through the technical overview, what we are doing there in this application before we dive into the demo. So what we are doing here, so the diagram above looks complex, but bear with me. I'll ensure that you understand that. I'll simplify that for you. So at the core, you have this AI agent, which is the LLM facing application. This is written in Python. So what happens is the workflow starts when a QA engineer provides that URL to this application and asks that, hey, can you do the automation testing for this particular URL or web page or web application, say, for example. For the sake of simplicity for now, because I did not want to make that demo hugely complex setup. So I have just provided one URL and we'll see that in the demo. But this is where QA engineer is invoking the AI agent. Now, AI agent has been provided with instructions that it first needs to launch the browser using the Playwright MCP server. This is where the browser control is happening. Now it launches that browser, fills the URL in, and you have that intended web application or web page open now. Once that is open, then the agent is also instructed that can you analyze all the components here on the web page and create a test plan. Okay. Once it creates the test plan, then because we want to save that test plan, right? So this is where the file system MCP server comes into picture. So it does the file operation, saves the file. Okay. Once this is done, the next agent instruction, which is again in all plain English, I'll also show you the instruction file as well. So agent is then instructed that, okay, once you're done with this, then proceed with the execution of test results. Ensure that you are capturing all those test results and evidences as well, and generate a log of all the actions that you have done. If there are any screenshots that you may have felt that are relevant for me to take a look at later, save all of that on the file system. And this is where that file system MCP server is coming handy, as it is equipping my agent or the LLM facing application to do those activities. Because I kept on saying this is LLM facing application. So this is that LLM model that is hosted on my Azure subscription. Yeah, so this is what the um, interaction circle. So that's how you essentially end up completing the flow, as the steps also mentioned below here. Okay. Now, before again moving on to a demo, Rashmita, quick check on any questions, comments, notes.
No, Bhushan, we are good.
Awesome. All right. Okay. So in the demo, what I'm hoping to do is I'll show you the functional behavior first, so that you understand what exactly is happening. And then we'll quickly dive into the bit of a code side of things, just to give you an overview of that, how easy it is for anyone to build this and get started quickly. Okay. With that, let me launch my VS Code instance. I'll bring it over and let's first run this application. I'll show you what we are doing here is we are asking it to open URL and let it complete the operations. We should be able to see some files generated here in FS files folder, which is empty currently. It is starting the application now. It has started my MCP servers. It has launched this browser. Let's wait for it to start taking actions. Yep, it is doing the test to do. Try deleting that. It might try and add one more. Sometimes it also takes a bit of a time to ensure that it is following all the test plan that it has created. And that's why you see these idle times here. But again, nothing stopping you from reconfiguring those instructions for your use case. For now, yeah, it has tried to delete that as well. Now it is still doing certain testing. We'll see what was the execution plan that it created, rather the test plan that it created, and then the test results of that as well. All right. Okay. So it says it has completed all the happy path and validated basic functionality. The reason I have changed the instruction is for the demo purpose, because I did not want to ask it to create a hugely complex and comprehensive test plan. Rather, I just wanted to keep it very simple. That's the reason. Now, as you saw, it was empty earlier. Now it has created a screenshots folder as well, and it has created the automation plan. I'll first walk you through. This is the .md markdown file that it has created. As you can see, it first created a test case, add to do item, description of that test case, what it intended to do in that test case, and then the expected result of that test case as well. It was able to do that using that Playwright MCP integration that we have done. And only after launching that browser and the URL, so it kind of understood that, hey, this is potentially the test plan that I would want to create. I'll also dive into the instructions, the way we have written those, because that also plays a key role in driving this entire application or feeding the input to large language models. But as you can see, right, so for demo, I've just kept it very simple. I've asked it to create a simple automation plan and save that in a file. And as we saw, right, it also tried performing certain operations and it tried to create those results as well. Let me close this, open this. Yep. So it is also mapping those test cases and the results that it executed along with the status here. So it tried adding to do item. So it tried adding the to do first as a single item. It says this is pass status for me. Complete the to do item action, mark to do as complete. It tried to tick that tick box, and that's why we saw that strike down to do item there. So it was again one of the test case and things like that. So it keeps on going based on the instructions. It also says It also tried an adding an empty to-do item, which was blank. Because of the nature of that web application, it doesn't let you let users add any empty strings in the to-do list. So it tested that as well, and then it captured the screenshot that it did not allow me that. Now let's take one of the screenshot for reference. Yeah. So it's one of the screenshot it was able to capture during the testing and also save that. Now, if I wanted to be a little more creative, I would have also integrated this in, say, by bringing in another MCP server that lets me or my LLM application send out emails, so that after the execution and saving all these results, I would have just bundled this up in a zip and sent to my some other delegation team that who would be interested in seeing these results. Or I might have also brought in the Azure DevOps MCP server, say for example, to dump this data in my test automation suite, or also could find a particular item from the DevOps, and in case of any errors or any screenshots that I am interested in, I would have just redirected those to a particular work item in the DevOps and then have those saved directly. Now you can imagine the immense creativity that you can bring in. We'll also cover that, like what is that next scope that you may want to experiment this with and extend this existing repository. But the whole point is the reduction in the amount of efforts that you may have taken as a QA engineer to write all of that code and do this same function, achieve the same functionality basically. Okay. Now with that, I'll first show you the set of instructions that I gave to my agent. So hardly 30 lines, not a single code line of code here. So what I'm saying is you're an automation QA engineer who is expert in writing and executing test cases, test plans, and test results for any web application or any given web application. Do these following steps again. So first phase is analysis and planning. All the detailed set of instructions, again, all in plain English. The next is execution phase, wherein I'm asking it that, okay, because now you're in the second phase, and this is where that state is coming into picture as well, because I said this is stateful, right? So application and MCP integration is aware that it first needs to complete this analysis and planning phase, and then it needs to enter to the execution phase. So the state is being maintained before even those different exposed tools or activities from the MCP servers are being called. So when it enters in an execution phase, you can see that it opens the web application. It has been instructed to open a web application, by the way, which we saw, and then execute test cases in sequence, perform interactions, validate results, take screenshots, use available tools for interaction. That's it. I am not even asking large language models that, hey, these are the tools available for you, and choose this particular tool for this particular action and things like that. I'm just letting AI to take that freedom and decide that what is the tool that it wants to make use of. If a test fails, capture error state. And finally is the reporting state. So whatever you do, I want these results to be saved on my disk currently, which is that FS files folder. So, and this is a particular format in which I want this .md file to be generated. And finally, provide me a quick summary of test coverage in only 2 lines. Yeah, and that's the reason it was able to show me the output of what it did. Yeah, which you can see here, the highlighted part. And finally, I am giving it an important note that complete all test cases and document results before closing the browser. So you can get, again, as creative as possible with your instructions, be very precise, provide those crisp and clear set of instructions for models to understand and start taking those actions. Initially, I had a huge comprehensive instruction set that I have given. It works, but then because it is very detailed, so takes a lot of time for application to analyze the test plan, create that test plan, launch the browser, takes all of these actions, and then finally write those detailed set of results. But just to save the time for the sake of this demo, so I have created this V2, which is based off V1, and have added to agent instruction. Now, where the real magic happens is, again, I'll quickly show. Again, as you can see, this is all driven by single Python file, which is again not huge lines of code. Most of it is declaration. Um, as I mentioned, I am using the Agents SDK here, and that also gives me providers to import certain MCP servers. These are different providers that it makes available. As you can see, MCP server SSE is something which is grayed out here. I have deliberately kept it because this is when you would want to incorporate those remotely hosted MCPs in your application. This is where it is used. But then for now, for demo purpose, I have incorporated MCP server STDIO, which lets me talk to my locally running MCP server. So it's the transport channel STDIO that it leverages. What I'm doing here, nothing fancy. I'm reading environment file that gives me details of where my large language model is hosted. As I said, this is hosted on Azure, so I'm just giving those different keys and points for application to reach to the large language model. I'm initializing my LLM client, okay? And now if I come here, my main program, what it does is, ignore this part because this is just the basic validation check that if npm is not running, then you want to ensure that you are throwing that error as well. But then this is that magic. I'm initializing my MCP server. This basically instructed to run locally. I'm using npx, providing certain arguments for that MCP server to kick off. So this is my file system server. This is my Playwright MCP server. Once those servers are defined and declared initialized, so here is that dot list tools method. So remember, we saw the tool calling part as well earlier. So this is now the tools or the methods exposed by your MCP servers. So my file server, MCP server exposes certain set of methods for my large language models to make a choice from and decide which one it wants to make use of. And then same for the Playwright MCP server as well, which I'm calling as automation server. Now, if you carefully observe the output here, so available file server tools, you can see read file, read multiple files, write file, edit file, and things like that. And then same is the case for Playwright MCP server, which is automation server. Start code gen session, end code gen session. Now, the beauty here is, as you can imagine, I have not coded these methods. I don't know. Okay, so this onus is with the MCP server provider. If required, I would have created my own MCP server and exposed my methods. But then because, remember the example of USB. So this is where I have kind of just plugged in two USB devices to my application. One is your file system, other is my automation server, Playwright. The USB device, what is in that USB device, who created those USB device? I, as an application developer, may not worry much. But of course, this doesn't mean that you should just blindly and cleanly trust all these USB sticks and then starts plugging those in, because there are certain security aspects as well, which is a separate topic in itself. I won't cover that in this session. So there are certain cautions that you need to factor in before you plug in these different MCP servers, particularly when you are not owning that is running behind the fence for you, which is who is hosting that MCP server, what could be the tools that it might be exposing, how it could be intrusive for your LLMs if someone decides to create that bad code and then influence your large language model based application in a certain way. So all of that still remains open and open for discussion caution when you design and develop such applications, but then you get the point. These are two USB sticks that I have stuck in my application, and then that's it. I don't do anything. I let my LLM decide that, hey, what is that tool you need? You have your instructions. Based on these instructions, take all the freedom, start choosing all those different tools that let you perform certain operations on browser, write results, document result, take screenshots, and etc. So this is as simple as that. And then that's it. I don't do anything. I just call this my function, run agent with servers, and then that's it. So what I do in this function is I am passing those two MCP servers that we have declared below. And this is where I am reading my instructions file that we saw earlier. I'm defining my agent. I'm providing those instructions read from the text file. I am providing those two MCP servers. I'm making agent aware here that these are two MCP servers that are available for you. And here is your large language model that is Azure hosted. That's it. I just do runner.run. And here is that input that QA could give. This is hard coded currently, but then um, this is not a limitation. You can just expose that as an API as well, or you can even expose that as an input variable. Your automation QA engineer can just feed this instruction in, and then that's it. It starts to execute as we saw, and then it prints the final output in the console as it has done. So, so this is that. This is the bit of a demo part and the code walkthrough as well. Before we move on to the next one, towards the end, I'll start talking about how this benefits and then how this is transforming the overall QA as a practice. But before we jump onto that, Rashmita, any question? Seeing it.
Yes, we do. We do. I'm
Okay.
just getting up on that on the screen. We have a question from Ashwin.
Mhm.
How to install Playwright MCP server on WSL2 in VS Code?
Okay. That's a good question. Because these MCP servers as currently running locally on my system. So I have not leveraged any WSL for now. So this is all being driven by the npx commands. But if you just even if you just search for this MCP server, there is this nice catalog that is getting built, wherein you find consolidated list of all the MCP servers. Playwright MCP server is just one of that from the list. Each MCP server, who is the provider of that server, generally ensures to also issue a set of instruction documentation to have this installed locally or even remotely with the choice of your technology as a platform. So I would encourage that to take a look at that documentation, and you may find instructions to install that with WSL locally.
Okay, we have another question. Can we use any other programming language to develop?
Yes, absolutely. So for now, because I have leveraged the OpenAI Agent SDK, that lets me write this using Python, but you can take any programming language. You can choose any framework of agentic framework. Basically, AutoGen is one example that I gave earlier. You can easily code. You can even take semantic kernel and start coding using C# if that's something that you prefer.
Okay, great. I think that's about it, and yeah, we can move on.
Okay, amazing. All right. So with that, I'll again go back to the deck. And let's first talk about the benefits and then how essentially it has now started to shift the role of the QA. Um, we'll cover the benefits part first. So as you can see, the autonomous testing is something which now is taking some shape because this is all getting driven by different agents and nothing stopping you from writing different agents as well. This is one agent that we saw in the demo, but imagine that you have an agents army responsible for doing a very specific job. So one agent is focused on your homepage maybe, and second agent is focused on a particular functionality, maybe a grid or maybe where you show finance data on your web application. So that agent is specialized in testing that part and then have those interacted with each other. So that's how you build usually the multi-agents framework. And the same can be applied for the QA purposes as well. But the whole point is because now it is letting you do that testing autonomously, driven all those by plain language driven instructions. So, which requires less manual script writing. And as a QA, you can start to put more energy on writing those instructions, ensuring that you are creating your QA automation strategy in a efficient way. Increased coverage is again one of that benefit that it brings to the table, wherein AI can potentially explore different paths that maybe if I as a human or I as a QA engineer may or might have missed. Reasons could be anything. Maybe I didn't even think of that scenario, or maybe because of the velocity with which I wanted to complete that, I missed that. But AI won't do that for sure, and you can rely. But again, this is all driven by those instructions. So, how accurately or clearly you draft those instructions and then take the AI charge of your application. This is all dependent on that. Self-documenting again. So as you can see, as we saw this in this demo, right? So that you have test plans that you can create. You can also document the results that are getting generated automatically. You can still keep your human in the loop to ensure that you are not completely offloading everything to AI and then just sit back and relax. But then you still want some human expertise to intervene and validate what it is doing is correct or not, what it has generated is correct or not. And then if I want to be 200% sure before I put any build in the production, then yes, I definitely would still rely on that human intervention as well. So reduced maintenance, as you saw, right? So the language of your choice and the autonomous nature of the application, which is driven by language and English particularly only. So you have not written a very complex code that is also tightly coupled with your UI layer, so which is very prone to any UI layer changes. And even in the long run, so these layers keeps on adding, yeah, as the application functionality grows in future. So your QA or the automation code that you have written also keeps on growing, and it becomes very complex at a point that any newly boarded member of the team or someone who is coming in as a new on your team becomes very difficult to go through and understand what was written there. But then this also not only creates that effort of understanding, but it also invites an operational or the maintenance overhead for operations team. Like once you deploy the system in production, then organizations will usually need to ensure that they are also maintaining a particular team to take care of that code, ensure that that is maintained as well. And then for any new features that are getting added, you keep on covering those in your queue as well. So this gives you freedom from all of that. And that has a direct impact on your development and release cycles. So it can significantly speed up all the testing cycle and also the regression testing effort as well. Now, how this starts to make a shift for the QA role, because traditionally the automation QAs have all written different scripts. This is why mostly they played role as a script writer. But now with these innovations, they can now think of pivoting into the role of test strategist and AI supervisor, because we still need some human in the loop there. Uh, as a QA, you can always keep that focus on defining your goals, reviewing, creating those AI plans, and also ensure that any complex edge cases which are pertinent to your applications are covered as well. And the multi-agent example that we talked about a while ago. So again, that could be one of that expertise of area of expertise wherein your different members from the different um, uh, parts of your team, or maybe people who carry different expertise of a particular domain, can put their focus on creating those instructions or very particular set of agents that are responsible for testing parts and different areas of that application. So that's about that. And with that, I think it becomes important for every QA out there to write this wave of AI and it becomes essential to have a basic understanding of the AI skills and technologies as well, the way, the speed at which this is evolving. So it would be good if every QA member is also aware of that. What is it that is getting built? What is it that the latest in the market and what is getting released? But the foundation of all of that is like you should be able to at least do the prompt engineering. So this is where you can ensure that you are providing those instructions to your large language models and guiding the AI effectively. Um, Understanding of, like I was mentioning, basic understanding of AI, any new conventions, protocols that are getting out there in the market, like MCPs, you should have basic understanding of those capabilities. There are cases when you definitely do not want to rely 100% on AI or servers like MCPs. So be aware of that. What are those use cases and scenarios? Like security testing is the crucial aspect of the application. So you do not want to probably offload that 100% to AI. You can definitely boost your own productivity if you are someone who is practicing in the security space or responsible for doing a lot of pen tests. You can use AI as your assistant to ensure that you are delivering with efficiency. But yeah, may not be a good idea to completely automate that altogether. Finally, not finally, but before that, so we also have this evaluations phase, wherein you still want to ensure that you are assessing the quality of AI generated results. Nowadays, there are also latest models. You may have heard announcement from OpenAI a few weeks back that they have now launched thinking models as well, so which are different than the general purpose models that they have. So you can also play around and ensure that, or at least try and integrating these models as well to ensure that whatever the results that your AI has generated as a part of the test case result, maybe you can put them again through the second layer of validation through those thinking models to recheck, revalidate that whether it has generated or it has tested your application areas properly or not, and then you can still bring in the humans in the loop as well to ensure that you also carry those very specific instruction domain expertise or based on your number of years of experience that you have spent with that particular domain or application and things like that. And finally, debugging. Yes. So troubleshooting when the AI or MCP interactions fail. So this is one overhead that it adds, but again, still minimal, I would call, is something as a basic skill that QAs should be aware of. Anyways, there is a very thin line separating QAs and developers when it comes to automation, because as an automation QA developer, you still are expected to understand some sort of programming frameworks like we have done with Javas, with Selenium and .NETs as well. So this is just one layer addition to that, wherein you should be able to effectively look at your agent code, understand that, and if required, should be able to also troubleshoot and debug those services as well. The next part talk about the extensions. Again, you can go as innovative as possible here in that space, but nothing stopping you from bringing the automation, exploring different MCP servers to do certain very specific things that we have been doing from years. API testing integration, right? So you can have those agents created that validates your different API contracts, make call, ensure that the responses are in the correct format, the JSON structure or whatever is the handshake structure that it returns are in the proper format or not. You can also do the CI/CD pipeline integration, wherein you can integrate these different agents in your pipelines and ensure that before even your development build goes to the QA environment, there are certain agents that invoke, do certain testing in some environment, and then gives me the result back. I have my other agent army sitting there who is responsible for validating those results, and then I decide that whether I want to pass this build or fail this build. Um, the test data generation is biggest challenge that most of the QA struggle with, because when it comes to doing testing with various set of inputs and data, um, you don't get those inputs quickly, promptly from developers or dev teams because they have done their own unit testing, but that may or may not cover the different aspects of the application with different set of inputs. So you can create your own agents which are responsible to take a look at the functionality and then help you generate the test data. You can still do the same for performance and load testing by creating those different hooks that you as an agent can expose and then start making requests at a certain velocity or speed to a targeted web application. You can also bring in your cross browser or device testing coordination between functionality focused agents and then let them do their job and then produce those consolidated results back. And finally, you can do the richer reporting and analytics. So the example that I showed you only is dumping those results in the markdown format. But then again, LLM has far greater capabilities to write only markdown formatted inputs. So you can even ask it to generate your CSVs, which then are fed to your reporting platform like Power BI or Tableau, say for example. And then you have those automated refreshed data sets, and at any given point in time you always see a dashboard which is refreshed with the results from your agents. Yeah, so you can take a look at the repo. Feel free to extend that further, and also I would be happy to understand what sort of ideas that you think of implementing with these frameworks like this. And with that, that brings us to the conclusion of the session, which is where we talked about the MCPs and then how what powers that it offers for your language models or AI tools that you're developing, how it how QAs can apply implementations like this for their automation strategies and then potentially achieve some form of automation testing or to do it autonomously. Um, as I kept on mentioning, this is just a conceptual implementation to give you a blueprint of what you can do with technologies like this. But like I mentioned, nothing stopping you from extending those further. And lastly, very important is the role of QA is evolving towards more towards strategy and providing oversight to integrated systems that are that consist of different components within them. And so yeah, that was most of it. I'll quickly take a pause before we conclude or move towards the conclusion of this session. Rashmita, any more questions that we see in the chat?
Yes, I'm getting up on the screen. You can see the question, right, Bhushan?
Let me pull up that window.
Yep.
Can I use this? So Chetan is asking, can I use this framework to test the components on the web pages and raise any UI issues for desktop and mobile? Also, can I upload the screenshots to SharePoint or ADO? Yes, I think that, so firstly, that's a very good question. You can definitely use this framework or framework similar to this to do web pages testing. If there are any issues that AI thinks that is an issue or UI issue, you can pass it along as an output to different service providers. Like Azure DevOps is one example that we talked earlier. But then if you have something or MCP server that lets you talk to SharePoint, then yes, you can definitely integrate that SharePoint MCP server as well, bring that in as a third USB stick and then pass those results. Azure DevOps, yes, I remember 15 or 2 weeks back or 3 weeks back, Microsoft has released the MCP server for DevOps. You can also see that in the MCP server repository, which is out there. I'll probably also share a link in my repo where you can find the list of all the MCP servers available. You can definitely have that connected to your implementation as well. But for mobile testing, this is an interesting one because these MCP servers, when you run these applications locally, are currently running locally, and then I'm using STD transport mechanisms to talk to that. When it comes to doing the fully autonomous mobile-based testing. I don't think that would be possible, but then again, if you have an agent that is capable of launching the browser in mobile emulator, say for example, that also helps you achieve the same sort of testing. Then you can write your instructions in a way that when it launches the browser or a particular application, then it is ensuring that it is launching that in an emulated or in an emulator environment wherein you get to define certain dimensions for the screens and have those testing conducted. Hopefully that answers your question, Chetan.
Okay, we have the next question from Satish. What are the prerequisites required to execute this example project on my
Yeah.
laptop?
So Satish, for this prerequisites are you will need Python. You will need to install the OpenAI Agent SDK, and you will need to ensure that you have Node server running on your system. So the npx command that we saw. So these uses or these make use of the Node server to ensure that the MCP servers are running as a part of the sub process of this application. That's the beauty of Python that you can leverage. But yeah, nothing apart from that.
Okay, next question from Harshit.
Harshit says, hey, can we use latest MCP server released by Microsoft for Playwright as other options or execute automation MCP server? Yes, you can use that, Harshit, for sure. I don't see any issue with that. If there is a Microsoft implementation of that Playwright, if you see that is released as an MCP server, yeah, nothing changes as a major component change in the uh, application that you find in the repo.
Okay, the last question is again from Chetan.
Yep. So Chetan says, how can I test for components on web pages? What I assume here is components as in different sections on web pages. So maybe on the top right side of the screen, you see latest news. On the top left side of screen, you see latest announcements and something like that. If that's the assumption, then yes. Maybe then again, to make it instruction driven, you can ask your agent to take a look at only a particular section of that web page. To make it very clear and crisp, you can then start to merge a very specific instructions like maybe that section is under the particular header, and that grabs the agent's attention to only look for that particular component. But would be interesting to see. Uh, Again, I have not done this hands-on myself, but I think this would still work because um, the Playwright or any MCP server that has capability to see through your browser, AI can instruct to get that focused on a particular section area and then have that testing conducted. All right. I think hopefully that answers your question, Chetan. But again, to if there are no questions, Rashmita, can we move on to the next section quickly?
Yes, sure.
All right. So thank you, Rashmita. So, folks, again, thank you so much for listening, tuning in. If you still have any questions, I'll be happy to discuss those. Also, discuss any potential options that you are thinking to extend or bring any innovation to your implementation. So, feel free to drop me a note on Twitter, or I'm also available on LinkedIn. But yeah, and you can always comment or report any issues on the repository link that I have shared. Cool. All right. I think thank you so much once again. Thank you, Rashmita, for organizing this.
Thank you so much, Bhushan, for hosting this session, and thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming sessions. Also, we would appreciate your feedback on today's session as it will help us to curate future session. Please scan the QR code and do share your feedback. Today's event ID is 25671. Thank you all once again and enjoy the rest of your day.